stored in a single repository, which like more than 2 billion lines of code. And there is no branch. Everything is built and tested continuously from here. Which sounds strange because usually you want multiple branches, but that actually gives us a lot of advantage. And a lot of smart people think very hard about this, and they decide that building everything from here actually gives us the speed and the convenience that we want so that we can move faster. And most engineers have read access to the whole repository. So everything is shared to everyone, which sounds strange, right? Because, like, there's a lot of IP inside the code. Why do we care about those IP? So that's another story. But basically, I think we understand that people can steal our code. And one of our assumptions is we need to be safe, even if people don't know how the code looks like. They'll get access to all the code. So we build the security based on that assumption. And another point is we need to move very fast so that even if someone copy our code, they couldn't copy fast enough, because we need to build, we need to innovate and a lot of stuff build up like our technology stack so fast that even our competitors copy our IP, they couldn't keep up with it. So to make any changes in the repository, in any folder, the engineers have to get approval from the owners of that specific folder. And the way they do it is they send a CL, they send what we call a chain list, which consists of, which is basically a patch. And the patch has to be reviewed, and review is mandatory. Like, it's a must if you want to commit some code to the repository. That code has to be reviewed. And the reviewer insists very high quality. So this is becoming the culture of the development at Google. And this actually provides us tremendous value because we can make sure that nobody alone can make any changes in our production system. Because if you want to make some changes, you have to get approval from another engineer. So from the attacker perspective, they have to compromise at least 2 engineers, to backdoor, to insert something into our production system. Our engineers make a new change every 2 seconds. Like, that means by the time I finish the sentence, there are 3 or 4 new changes committed to our repository. And that, like, I think by some measure, half of the repository are changed every 6 months. So we will delete code, add new code, change existing code, and we will constantly doing that all the times. We have more than, I think, 25,000 engineers. But there are also a lot of code that stay put for a very, very long time. And that actually brings us some challenges in dealing with that. So we now have 7 products that have more than 1 billion users. Google Search, YouTube, Android, Chrome, Gmail, the Play Store, and Google Maps. A lot of people and businesses entrust with us, they're most sensitive in private data. So the security of these products are of paramount importance. If any of these products got compromised, the security of the large part of the internet will be gone. Like, raise your hand if you use, your Gmail account to sign in to Facebook or your bank account. A lot of people do that, right? So if Gmail is compromised, you can compromise a lot of things, not just Gmail, not just Google. So this is my job at Google. Like, I'm part of a larger team to make sure that these products are safe from, the threat that we care about. And here are some of the challenges that we are facing with this scale. Some of these challenges are pretty unique. Like, stop okay. So a huge part of our code base were written a very long time ago. Some of the code date back to the early days of the company, like 15, 16, 17 years ago. And the engineers at Google, I usually move teams every 1 or 2 years. That means there are lots of code without clear ownership. When people develop something, they move on to work on other things. And now the people that become the ownership of that code, they are very afraid of changing it. They are very afraid of doing anything with that code, because if they change it and it breaks, they may not have the know-how to fix it. So it creates challenges for security, right? Because when we find problems or security issues in this code, it's very hard. It could be very hard for us to determine the priority and the severity of the bugs. Because if the code is dead, then we shouldn't fix it. We just ignore it. But if it's actively used, then we need to fix it. But how do we determine that if the owner of the code doesn't get a clear understanding of how it works? That's the first major issue that we found. The second issue is we wrote a lot of code ourselves, like 2 billion lines of code, but we also use a lot of third-party code that we bring in from open source projects or we license from third-party providers. And these codes are usually of unknown quality. And the challenge that we bring is how do we make sure that if there is a known problem or if someone discovers a new security issues in these packages, we can update them in a timely manner. We can move everyone to the new version. And if you have one single package, it's very easy. But if you have 100,000 of packages, the problems becomes intractable very quickly. So we build tools, and I'm going to share how we deal with this thing shortly. The second challenge is the next challenge is the state of the business that we are in. There are tremendous competition in the Valley and around the world. A missed opportunity can cost us, millions of users and billions of revenue dollars. Users also have a very high expectation for us, and so we have to keep the bar very high. And at the same time, we also want to innovate, to ship new features, to provide new products as fast as possible. So there's a balance between, moving fast and making it right. Because if you move fast, you are sure would have to cut corners at some point. So our job is to make sure that we draw a line. Okay, this is okay to do. This is not okay, and we have to. Sometimes we have to, let people to launch things that we know risky, but at the same time we feel okay, it's okay to launch it now, but later on we can fix it. So, and time to market is of tremendous pressure. A lot of teams and a lot of times we security engineers are under tremendous pressure to launch things, to let people to launch new things, because the competitors are way ahead of us. So we need to catch up and want to do something, the management want to do something about it. The next challenge is the data that we're hosting for our users are, attract many powerful and formidable, adversaries. 3-letter agency all over the world, they want to hack us. You read from the news that, we cooperate with the NSA or I don't know, whatnot, but it's not the truth. They really, really try to hack us, and we really work it really hard to defend our data, our user, our infrastructure against them. These adversaries are very powerful because they have a very large budget and they have a very large pool of talents to draw from. And they are very, very, persistent. They don't give up very easily. That's their job. Their job is to hack us. And so you don't give up your job, right? Because you get paid to hack people. And they are willing to go the extra mile to compromise us. They plan in years. They're not they may be planning 10 years ahead and then have a plan to get that goal in 10 years. So it's tremendous difficult to defend against these people. And they would love to find vulnerabilities in our products to extract data. You know, if they find a way to get everyone emails without having to hack our data center, they would love to do that. Another thing is, aside from the three-letter agency, you know, attackers, we also target onshore other attackers, like criminals, you know, war students or researchers. Anything, anyone coming up, the first place in the world that they want to try is Google. Like they try all sorts of new attacks against us because, you know, the media love, you know, to report these findings. So if someone found a way to hack, I don't know, a small startup, nobody would care about that. But if someone use the same technique, use the same bug, use the same vulnerability to hack Google, that would be a big news. So, and if you look at this point of view, at this angle, you will see that security is a VR issue as well. It's not just a technical issue, it's a VR public relations issue. Because we want to make sure that our user can trust us. We want to show them that we are competent, we know what we're doing. But sometimes the actual security that we provide may be different from the security that user perceive. So we really want to try to make sure that the perceived security that user outside